Okay, I'm sorry for the glitch. Validating existing designs. The next logical step is to validate existing part or mold designs to ensure manufacturability and also to avoid the time consuming and costly production delays, what we discussed in the earlier slide. While this results is more value realized from the use of simulation, there is still the potential for significant hidden costs because parts and molds are not being optimized. Let me say an example. Without optimization, companies are not determining if the parts could be made thinner, reduce material usage, decrease cycle times, using less energy, and lowering overall costs. So that I just make some profitability today because any injection molding shop would work on thin margins almost all the times because of the competition or various reasons, various commercial reasons, of course. So how do I optimize and how do I make some money out of it, make some extra money out of it when I just optimize all these things? So limited application provides benefits to a small number of parts, and there are hidden costs due to the lack of optimization. There are a lot of hidden costs applicable, which we may come to know only when we see the balance sheet. And then preferred way. Now we have seen the problems. The preferred way to optimize part design and simulation, mold design and simulation, mold build, production. Of course, I'm not saying here I can completely eliminate the trial process, but if I'm, if I'm proving my mold in 5 to 6 iterations or 5 to 6 trials, I can bring it down to 1 or 2, or maybe maximum 3. So it's 50% of that is saved, and that would also a point of ROI. That would be the return on investment on your solutions. What is there in the coming up slides. Today, world-class companies are using the simulation the new way in the earlier stages of part and mold design, allowing more users to optimize more designs. So, regardless of what phase of the process a product development team member is involved in, they can take advantage of simulation to ensure that their product design or their mold design is optimized to produce the highest quality parts in the least amount of time at the lower cost. What happens when I do the part design and mold designs and also the simulation at the early stages, I have more scope to correct it in the earlier stages in the virtual world, so that I don't keep my hand on my head when it comes to the real time manufacturing and production. So looking at all these things, how to optimize part and mold design at the earlier stages of design, and also to predict what would be the manufacturing defects I may foresee in this particular part. Throughout the process, I can do a lot better, and I can save a lot of money and time in this, and also I can increase my productivity in terms. Using simulation as an integral part of the part and mold design process provide the ability to optimize designs for manufacturability, so that a lot of benefits comes to it. When I say cost of change versus impact of change, why should you be concerned about using any plastic simulation during the earlier stages design? Because that's when the cost of change is least and the impact of the change is highest. In other words, if I have to say, when you make changes during part design, it's a 3D CAD model, but if you have to make those changes during part production, you might have to be rewelding and cutting steel, a very costly and time consuming process. Here in the CAD, if I have to do the changes, it's all about modifying the geometry and adding some features or removing some features or tweaking it in the part design inside my CAD environment. But if I have to do it in real time, it takes a lot of time, and it's a costly process again. Because of the inherited constraints, the changes you make at the point may have little to no effect of the manufacturability of the part also. So part design, mold manufacturing, part production, product launch. Here you can see in this slide the impact of change and the cost of change. So how it goes. So that now we introduce SolidWorks Plastics. That is where we are introducing this for companies that design plastic parts or injection molds. SolidWorks Plastics helps us to predict and avoid manufacturing defects during the earlier stages of part and mold design, eliminating costly mold rework and improve part quality and decreasing the time to market. When I say what is the value it brings in, to the table. It's today 80% of the more than 80% of the plastics parts are injection molded, and injection molding is a process of complex mix of time, temperature, pressure, material, tooling variables, manpower, a lot of things involved in this. And also your injection molds ranges in cost from more than $10K to millions, and mold rework is costly and time consuming. Here, instead of making the mold and then reworking on that, I would do everything inside my CAD window, and I just produce close to perfect molds, so that I avoid a lot of time consumption, and also in turn I just save a lot of money. So using SolidWorks plastic simulation to avoid just one round of mold rework can result in a positive ROI. Say for example, you are making a mold of around 25 lakhs, and you have to rework, and the amount of time you invest, amount of manpower, amount of material you invest in reworking that, if you consider all those things, and if you see at plastics SolidWorks plastic simulation 2, you get a positive ROI. So this is how the value proposition is. Great thing about SolidWorks plastics is that using it in just one project can justify the cost of the software. So here, when I say SolidWorks Plastics, what are those key capabilities? We are going to see that in the next slide. Extensive database of plastics materials means we probably have the materials our customers are using. When I say extensive database of plastics material, may depend on the family of the polymers, makes the blends, the make the like 3M, or so many materials, allied this thing, and so on. Also, I may use the material which is supplied by the customer. I just specify it to the customer. He will make the blend and whatsoever wanted, and he produces the material. And there are a lot of standards. There are 4,000 plus materials are available in my database, which can be sorted by the family or sorted by the suppliers, which we are going to see it in the demo. And also comprehensive range of analysis capabilities and results, like in most cases more than the competition offers for that what you are using. Typical SolidWorks workflow that minimize learning curves and help the user to get the valuable results as quickly as possible. So differentiators. Now, why SolidWorks Plastics? Yes, of course, I have key capabilities like extensive database, guided analysis setup, and result interpretation is so easy. But what is that differentiators? That is fully integrated inside the SolidWorks. Any of you who are listening is as SolidWorks users and SolidWorks simulation users, the power of this, where it is integrated inside the CAD window, so that I need not to leave my window at any given point of time. I can just start here and end here. And also, needless to say that easy to learn and easy to use, SolidWorks is a differentiator. Major differentiator for SolidWorks is that is very easy to learn, and learning curve is very short, and also it is fast and accurate. I would stress on this fast and accurate, because fast, yes, it is easy, and the engine is robust and it gives me the fast results. Accurate, yes, I can confidently say, because the mathematics behind whatever the simulation, whatever the analysis we do, cannot be changed. It is common for all the platforms, but the way we utilize that, or the way we work, is what more important. So accuracy is dependent on the mathematics. Mathematics cannot be changed, so it is always accurate. So this is how it is. Now now this is what the SolidWorks Plastics is. Now let us dig more and take a closer look at the product, how it is designed, and how it is available in the for the utilization. SolidWorks Plastics standard is the base one. As you know, in SolidWorks we have the nomenclature of standard, professional, premium for all the products what we carry. So SolidWorks Plastics standard is that for the basic one for the part designers, wherein I can answer the questions like, will my part fail? I'm designing a plastics part which is meant for some application. I just need to take care of form, fit, and function as a designer. Yes, I have taken that. I have just covered all those form, fit, and function requirements for the part, and I have designed the part. But that is not enough. If it is a plastic part, I just want to analyze, or I just want to see, or I just want to study whether will my part be easy or difficult to manufacture. If at all it is manufacturable, will my part fill when I just get into a tool, and where are the weld lines may occur, which affects the capability of the aesthetic part of the part, or the strength of the part, or the functioning of the part, and will there be air traps, which also affects the functionality of the part and the durability of the part, and so on. And then simulates the mold filling stage. I just want to know how many seconds, or how much time it would take to fill. And optimize part designs for manufacturing. I just want to see the manufacturability by testing the uniform wall thickness, or the drafts provided is proper, and also I can determine the gate location, best gate location, which would be the best gate location to avoid defects and also get the fill in the required or stipulated time. And also I can choose what is the tonnage of machine I have to load this particular tool to get this molded without any problems. So these things we see in SolidWorks Plastics standard, which helps me in seeing all these things, studying all these things. The animation also is provided in the profile of the melted plastic as it flows through the mold, so that it's as if SolidWorks Plastics provide a window into a mold, because without simulation, it's very difficult to understand what's happening inside your mold. I can just take sections, but without animation, I cannot see whether how it is going to fill all those things. So next one is SolidWorks Plastics Professional. Plastics Profession is little more added, it comes with little more added value features. There is a value addition in terms of, it is targeted for the mold designers and mold makers, and bit deeper into the process, allowing users to simulate both the filling and packing stages. Standard helps me in see the filling stage, but here in professional, it also helps me in filling and packing stage of the injection molding process. You can analyze and optimize single cavity, multi cavity, and family mold layouts. Automatically balance your runner systems if you are running multi cavity molds, and determine maximum injection pressure requirements and molding machine size, and also perform many advanced analysis types, including your insert word molding, I would say example of a, a connector wherein you have to have the metal as well as the plastic. And then two shot molding, maybe I would take an example of a toothbrush where you have two shot molding, gas assisted injection molding, wall gates wherein you have to have the gates to be shut and open at different stages so as to make your filling uniform and all those things. So these are the things which I can do with SolidWorks Professionals. Mm, so it much more capabilities. Also fiber filled materials also can be simulated inside SolidWorks Plastics Professional, wherein it is for mold designers and mold makers. It is for mold designers and mold makers. And also it gives little value addition from the standard module. Now let's look at the ultimate version of SolidWorks Plastics, which is called SolidWorks Plastics Premium, which is for my mold designers, mold makers, and CA analysts, wherein I just want to analyze different types of analysis, like in order to support that targeted at mold designers and mold makers, but also can be used by advanced analysts looking to perform in-depth mold cooling and work page analysis. In the simple nomenclature, if I have to put it across, my standard comes with fill, professional comes with fill and pack, and then premium comes with fill, pack, cool, and work. All these functionalities which is required to deeply analyze the injection molding process. Though this also design and analyze injection mold cooling line layouts. As you see in the picture, these are the layouts built for cooling, and also you can see the impact of how good my cooling is or how bad my cooling is, what is the effect of the cooling layouts, what I have designed, so that I optimize the cooling layout so that cooling is adequate inside the mold. And also for the bigger parts, which is more in length and width, it's always known that you will have a warpage. The warpage, bending of the part at one side, it is just pulling off the part one side because of the warpage, because of the various reasons like material strength or material properties, mechanical properties, and so on. So that also I can analyze using the plastics premium, wherein analyzing the warpage at the earlier stages helps me in altering the part design to get the proper dimensions into the while before going into the going to manufacture the core and cavity, like morphing it digitally to get the required size. Or also I can plan for a fixture post molding. My part is taken out of the mold, ejected out of the mold, I can put it in the fixture. So fixture dimension, I can find out, predicting the molded part warpage in this stage. So the standard, professional, and premium. These are the three modules available, or the flavors available in SolidWorks Plastics. Now, apart from that, in order to support so here you can see one more example of warpage. And apart from that, what we have is the world-class service and support, wherein we have developed the SolidWorks Plastics Dream Team, the world's largest field organization with plastics domain experience, wherein they have 400 plus engineers worldwide and growing. They can help your company select a plastic material, learn and follow the best practices for plastics part and injection mold design, and of course, provide SolidWorks Plastics training and support as well. So they help you with material selection, part design, mold design, also SolidWorks Plastics training and support in terms of how to use the SolidWorks Plastics to get your results optimal. So this is the dream team which is there worldwide, which helps me through the blogs. You can stay connected always, and you can get your queries solved with this team. And also, apart from that, this is the SolidWorks plastics, how it has been evolved and how it has been structured, and how we are going to help you and support you in terms of the the usage and the domain expertise. But also in SolidWorks Plastics 2015, we had some enhancements into that. The current version of SolidWorks Plastics is 2015 as of SolidWorks 2015, wherein we have built in new features like e-drawing support, and then nominal wall thickness advisor, and then symmetrical analysis, venting analysis, and also non-orthogonal voxel meshes we'll discuss later, because we have different types of meshes. I am just going to show you what type of meshes we can achieve inside the SolidWorks Plastics. So of course, as our all our simulation tools in SolidWorks carries, this is also an automated machine, and you can control the mesh according to your requirements, however you want. Now let us have a look at one by one. E-drawing support. You can export plastic simulation results as e-drawing files. Also, our SolidWorks simulation files allows you to share your result between key stakeholders without having to install SolidWorks or SolidWorks Plastics. Now you just want to share your results between your customer and your suppliers, whomsoever. You just need not to expect they also have SolidWorks, because you can see the you can send them the e-drawing support. They can view it, they can see the results, and then they can add annotations and notes to your result plots, and also you can archive results. So this gives you the better communication with your customers and sub vendors or whomsoever who are the stakeholders of this particular activity or project, and you can archive the results as well. It works as good as your any other files which you send in e-drawings. And also, nominal wall thickness advisor determines the overall nominal wall thickness and the percentage deviation from the nominal value, which helps me in designing. Also, tool allows this the primary design role for injection molded product is to maintain the uniform wall thickness, because uniform wall thickness leads to uniform filling patterns, pressure distributions, cooling times, shear stress, and volumetric shrinkage. So for that, Parts with uniform wall thicknesses have optimized cycle times and also are less likely to warp or deform out of shape. So this helps me in analyzing the same, and also tool allows user to follow the primary design rule for injection molded parts. And also symmetrical analysis. Say, when I say symmetrical analysis, it is like this: save time by allowing analysis of part of a model instead of the full model. If a part is symmetrical, you just take a part of it and you do the analysis so that it is having the symmetrical results throughout your part. Model must be symmetric about a plane or two planes of symmetry or an axis, and ideal for large multi-cavity mold layouts. If you have, say for example, some components would be having 30 cavity, 40 cavity and all, there it is very much useful to take the symmetrical analysis and do the analysis on one symmetry, and the results is spread across to the entire layout, which saves me a lot of time instead of meshing the 40 cavities, 40 parts, and doing the runner layout system and all those things. Instead, we do one for one symmetry, and the results can be spread across. Venting analysis to analyze the vents. Of course, I can see the gas spots or the gas traps, air traps inside my plastics professional or plastics premium or standard. But how to design the vent? Specify explicit vent locations to avoid air traps. Okay, or to avoid potential defects due to trapped air or ineffective vent locations. I can specify the explicit vent location and also examine effects of specific vents. If I have designed a vent, I can see the effects of those specific vents using venting analysis. And also earlier stages itself, I determine the areas of mold that require venting, because I remember we used to make the mold first, and then we used to see how it is going to and where the air traps used to be. It is, I'm talking about a decade back. And also then we used to see where all the inserts required. We used to make a cut of that in the CAD tool, and then make a electrode type, and then spark it, and then insert it in the core or cavity. So this was a long process, and it was time consuming, and these things used not to be included in my PERTs or Gantt chart where the production planning or the process planning is done. So it used to take a lot of time, and we used to deviate from the schedules most of the times. So these kind of problems can be avoided when we have such features or such tools in place. Non-orthogonal voxel mesh applies to hexahedral meshes. A new mesh algorithm as non-orthogonal voxel has been added in 2015, because the new measure automatically adds more elements in the areas that need more than one layer of mesh. And also, this allows user to generate high quality meshes and better analysis accuracy, resulting in more accurate results. Because in the simulation in the CAE, it's always I'm sorry. I hope it is audible now. Okay. So ultimate mesh plays a very pivotal role in any of the CAEs, any of the FEA studies inside aided analysis engineering. So here, different kind of meshes helps me in getting the better accuracy of the results in SolidWorks Plastics. Now let us have a short demo. I'll show you how the product looks and how simple it is, and then we'll come back to conclude and take the questions. Okay, so we are looking at a part here, and we are inside the SolidWorks window here. This SolidWorks window is having a regular CAD window wherein I have model and all those things, and I just change this to the shaded view with edges, and you can see the part here which is having a metal insert as well in the middle. and then having a lot of ribs, and also add channel design here now with the edge kit here. And now what I am going to do, I just want to do the analysis for plastics. Now what I am seeing in the ribbon bar is SOLIDWORKS Plastics window, when it says how to get started. There is a wizard and the more layout wizard, and then the mesh model and the transparent model and cavity visibility and so on. Now here, how to get started. Here I just come to the plastics tab. For that I just need to go into the add-ins, as we do for most of the add-ins, modular add-ins inside SolidWorks Plastics, and I just select this SolidWorks Plastics, so I can see this plastics manager here. Now I can see the mesh capabilities. Now I say meshed model, you can see the mesh here. When I say mesh, I can just do it as manual mesh or shell or solid mesh, and then it could be manual or automated. When I say manual, I would be having better control. I just select manual. Now I can also have this runner and cooling system design and virtual mold generation for this, when I just want to study the create the mesh. In the next stage, what I'm going to do is I'm going to add what type of elements I want, and what is the domain I'm looking for, the procedure here, what is the triangle size I'm looking for, and what is the local refinement I need. If I say I just want to have the refined mesh in some critical areas where there is a contact of metal and plastic, now I can choose that. I can set, or I can automatically ask the software to do that. I just say select through. Okay, I just selected those edges, and triangle size here would be 0.5, and I say assign. So domain is assigned. I say assign. Now I just have the triangle size of 3 here, and say mesh, so that I can see the meshing happened. However, I have specified, I have set some local refinement in some areas where it takes the refined mesh of size of triangle size 0.5, and other areas as per what I have suggested. You can see here the edges where I have specified is taking refined mesh, and the other areas as specified. You can see those difference here. Now this is how I just create the mesh, and in the next stage I can see the properties or the summary of the mesh, whether it is waterproof, that means there is no gaps or there is no patches, and then element intersections, if there are any bad elements in that, how much percentage very bad elements, and I can see through where are the bad elements, of course, if there are any. Now I just close the summary. Now here in this process I can have the node merged, auto merging of nodes, and delete triangle and make some triangles, overlap region, edit mesh. You can also see the summary, mesh topology, all these things you can study. You can see the mesh topology here, what are the non-manifold elements, intersection elements, and all those things. Now in the next stage I can convert it into tetrahedral or hexahedral mesh, then on to non-orthogonal voxel mesh if it is required. So tetrahedral mesh here, I just go along with that. Now we can see the tetrahedral or hybrid and minimum thickness of boundary layer and all those things. And I can also set the profile, and then say select, I say transform, so that my mesh is going to be transformed into tetrahedral mesh or hexahedral mesh or whatsoever I've selected. I can also make it as hybrid, and you can see the cross section of that. See, it's as simple as this. It is throughout how many triangles, and it also show the cross sections to show you that it has been taken throughout the part, throughout the thickness. Now say next, and I'm done with the machine. So it writes all the required files and 3D data, everything inside the same folder from where we are working on, so that I need not to search later, and it is all stored inside this, and you need not to give any links to read that. It is all automatically linked inside. Now if I have to see the machine model view, this is how it looks with all the proper definitions which I have given. Now next comes is material, wherein I just need to add the material, polymer material. I say open database. I can see the default database. In the default database, I can sort it by family or sort it by company. When I say company, the supplier. When I say sorted by family, it is on the based on the nomenclature of the parts and plastics material like ABS, ABS PA, ABS PET, GAS, GPPS, PA, whichever I want, I can choose. Inside each and everything, I have the brand names also as well, like Stylac, Polyman, Terluron, and so on. BASF, Bayer, whosoever produces or supplies these kind of materials, or with the code of the material is available. Now if I have to sort it by company, I just don't know what family it belongs to, but this is what the the commercial name of the plastic material, and it is supplied by so and so supplier. I just go and sort it by company, and I can see this. I'm getting the material from Asahi, that is Kasai Stylac is the 250 is the material, or I'm getting it from BASF and ABS Terluron HH 106 is the material, or turbulent, luran, polystrol, ultramid. Also, I can search, because of course it's a huge extensive database. I cannot keep on scrolling. I can use the search window, and I can give the name. Terluron is what I'm looking for. I can see the list of materials with that particular name, so that I can choose whichever I want. I can just streamline this activity, so that I just don't waste a lot of time in searching the material. This is default database, and also I can set co-injection for if I have to have two different polymers injected inside the same mold for the co-injection, like the example I said is toothbrush handle will be of different material and the entire body is of the different material. In that case, I can set the co-injection as well. Now what is that user defined database? In this extensive database of 4000 plus materials, you don't have the material which you are looking for, but you have that mat file, the properties file. I just go to the user defined database. I just create one material. I just say delete or add material or add product. In the polymer material name, I just give as sec or whatsoever. I just give some name. In that, I just bring in plastics materiality file. I can just get into this my.materiality.portal, that is from Simpoe, where you can see the materiality file, and you can log on and you can add the file whatsoever it is required for this. Or I can, if I have the file already available with this data in terms of BIN or XLS or XML, you can just load that, so that all these properties would be loaded and you can see the properties here. I hope it's clear now. So material is added, and your favorite materials which you have used very recently would be listed out here. You can use which you want here. I just go with the generic material of ABS here. And also same applies to mold database. I have this default database of mold material like aluminum alloys and copper alloys, other metals, steel, carbon, plain carbon steel, titanium, zinc, whichever. And also for each and every material, you can see the thermal conductivity, density, mold material parameters, specific heat, everything. And also here you can see the user defined database. You can set your own materials. Now comes to Input of material is over, and then process parameters, fill settings. I can just ask to take it automatically for the first iteration. Let us see how it goes. Then I can change whatever is required. I can reset injection pressure limit, mold temperature, melt temperature of the material which is taken from the database, material database, and then pack settings in terms of pressure holding time, pure cooling time, which is taken automatically, and then warp settings, what is the ambient temperature of the mold, 25 or 30 degrees centigrade, and the gravity direction is what, z direction or x direction, whichever I can just set. Next, the boundary conditions, material is set, process parameters are set, mold wall temperature, you can set your wall temperature here, apply, and then runner element if you are using the hot runners, and then filled hot runner, what is the temperature there, and then air vents, where all you need to specify the air vent. Select the location of the parts where vent will be specified in the mold, and then click apply. You can just select some area and say apply, and then warp boundary, and then advisor nominal wall thickness. You can open the advisor and see the nominal wall thickness as well. By percentage or by value you can specify. Maybe I may not be able to run this. I can just show you because of the internet lag, so I just go ahead with whatever I have. Okay, I'm sorry, it started already. That's fine. Let's wait for a few minutes or seconds, one or two, couple of seconds or minutes it will take. So you can see here, designing the part with the most uniform nominal thickness as possible. You can see the plus or 30%, or minimize sinking, warping, residual stresses. Ribs should be placed in the areas of stress instead of increasing the wall thickness. By minimizing the wall thickness, you will reduce the cycle time, short weight, and weaker cooling. So these are the tips you can see inside the wizard as well as in the manager. And you can set the nominal wall thickness by percentage or by value, and also you can specify the nominal wall thickness what you are looking for, so that it analyzes the model completely and gives you the it is automatically calculating the thickness, and we are around 60% done by this time. Yeah, we are almost through now. It is around 10 to 15% is remaining, and we are going to see that what result it throws up on the screen. Meanwhile, this results, there is something called as wizard, which also helps me in guiding the step-by-step process inside injection molding. Now I just went through the nominal wall thickness. Now all setting all of this, I just also want to set the injection location. I just double click on the injection location node and the pointer diameter as well. Injection system, how many, and the material injection range, it's that volumetric ratio, or it's time seconds filling time, based on the filling time. and if I have my multiple materials start and end range, and here I can just go with add injection locations, or and also add injection locations automatically, and you can also predict the flow pattern as well. I just say predict flow pattern, and I just select this add injection material, I mean location. I just select this node, and I just click on this so that it is added. Say okay. So the material injection location is added. Now I can run this flow pack warp results. See, if I have the standard, I can just get this. If I have a professional, I get flow and pack. If I have the premium, I get all these combinations. Now I just need to run this study. I just say read flow. I mean, I'm not running the study because it will take little time, and also we are on the internet. So when I just run any of the study, I can see the results like this. If I have done all the flow, pack, and warp three kind of studies, I can see the results here and interpret the results. What all I can get: fill time, what is the time taken to fill, pressure at the end of fill, with the graphs and with the animations. Now if I have to see the fill time animation, I just select that and I say animate it. Also I am seeing the value flow pattern, because remember when I just say predict the flow pattern in while selecting the gate location. So here what happens, based on this also I can send it to the e-drawings, the same animation. Let me stop this animation. Now what else I can see: shear stress, volumetric shrinkage, what is the percentage, and what is the cooling time required. When I say cooling time required in this flow analysis, it's not with a cooling layout or whatever I already designed, but it assumes the ideal condition and gives me the time. But this can be drastically reduced. This cooling time can be drastically reduced by adding the proper cooling channels and then doing the cooling analysis as well. Then the sink marks, it's very obvious that where there are ribs for the strengthening, I can see those. And then yeah, just a minute. Yeah, so here ease of fill, and then weld lines, where are weld lines may occur, and then air traps, where all I can see the air traps. Let's run only one study, the flow. Okay, sorry. I just run the flow again. I just replace the existing one, and we can see that it is running the flow study here, and it may take a couple of minutes here again. I just wanted to show you what is the speed of running the analysis. Let's run this, and also it gives me the node information throughout when it is running the flow study. And of course I can just hide this analysis manager, and analysis manager is active, and I can carry on with my different work if I want to. Now let us have a look at warp results meanwhile. Yeah, this is my warp results total. What is the deviation is 1.8 mm. In the x direction it is 0.7. In the y direction it is 0.8, and in the z direction it is 0.1. Now how do I see that? In the z direction or in the x direction, if I have to see that, I can just animate that as well. Deformation scale, I'll put it as 5, because I just need to exaggerate how it looks. You can see how it is. You can see the animation, and you can see there is a gap, how it is warping in which direction, what is the impact of warp. Also, let us have a look at flow. Okay, flow is running. These are the warp results, and I can just see what is the status of this as well. Okay, maybe it is going to take a little time. Let me show you one set of examples already. The results which is already built. I just to close this window and open that. And also see, pre-processing, the machine is automated, we did it, and then the analysis we did it. And now what remaining is how to interpret the results, the post-processing, how easy it is, and how we get the reports, how do we interpret the results. Now for everything I can also have this video recording done here. And then now I want to get the results summary. I just right click here on the summary and report, and I say generate. When I say generate, it gives me the material, all of the conditions here in the summary. And now I just fill in all the titles: report on analysis, date, department, design, institute. I just fill in what all I require. Introduction, if I have to introduce something about the project, and then generate GIF files of everything, and I'm done. You can see the report done in terms of HTML, in terms of Word, as well as PPT. It creates a PPT and give it to you so that it can be interpreted. The results can be easily interpreted with the videos, and in the HTMLs it also gives you all the animations of flow and warp and whatsoever. I just need to visualize in the results. It's taking each and every aspect. You can see a change. Now it is taking all the results. Meanwhile, I'm open for questions. You can shoot your questions on chat window so that we'll be able to see that and answer your queries. Yeah, report generation is finished. I put it on my desktop, and there is a folder created with all the given information, with all the HTML files and other files which is related to this report, which can be wrapped and send it to your stakeholders so that they can view all the results. I just say show the desktop. Inside that we can see here this reports, Word files, filling animations, and all the HTML related files. I just open this with Internet Explorer. We can see the model information and the material information And there's in the process conditions set, and then the flow results. Here you go. Inlet minimum coolant temperature. This is the flow result. Pack result. It's just building. Special node if any. Material parameters. Results. Flow animation. Pack animation if I have run. Warp animation. And then user defined if I have defined any other. You can just see all these things. And also if I just have a look at the Word document, it is also built on the similar lines when it gives the complete details with all the glossaries and the material information and the ejection temperature, glass transition temperature, process information. You can just see. So this is what all about SOLIDWORKS Plastics. This is just a simple example. I mean, due to the internet conditions and all those things, as this is a webinar, we chose to show a simple example. Nevertheless, if you are interested to see in detailed demonstration of plastics on your part or anything like that, we would be more than happy to serve you in that, and we can come to your premises. We can work on. Let us know how you want to take it forward so that we are there to support you on that. So let me know if you have any questions through chat. Right. So to summarize, using SOLIDWORKS Plastics during the earlier stages of part and mold design helps you to predict and avoid injection molding manufacturing defects, eliminate costly mold rework, improve part quality, decrease time to market. Any questions? Okay, I think no questions. Fine, if you have any questions, you can write back to me on praveen@beacon-india.com. I'd be more than happy to help you in solving those queries. and also to work together to if towards your interest of this predicting manufacturing defects. Let me know through. Okay, here I have a question. Does this included different types of gating systems? Of course, we can choose what type of gating systems we want to give inside the gating system. While we design the runner layout, we can also design how what type of gate we can. Parting lines can be chosen in my can we choose parting lines is the one question. Parting lines selection is while we design the mold, wherein I can do it with the SolidWorks mold module itself, wherein we have parting surface generation, parting line prediction, and all those tools available inside SolidWorks CAD standard, which is into mold tools. After analysis in the result sheet, we are not able to view the warp study. Is one more question. Yes, because I just started to run that warping and I had not included that inside my presentation because of the because it takes a lot of data in. So I can choose yeah, while creating the report I can choose what to be shown, what not to be shown. I have not chosen that. Can this presentation be available to download later on? Definitely, we are going to help you, and I would send you this the presentation to you and through email. What is the accuracy of the WARP results with respect to practical results? Is one more question. Accuracy is what I said in the beginning. The mathematics cannot be changed. The mathematics behind all the softwares are same. I would say accuracy is around 90% as far as I have seen. 80 to 90% as far as I have seen in my projects what I have done in SolidWorks Plastics. Hope you got the answers. I also I've taken down these questions. I'll also write back to you through email the detailed answers for these questions as well as for what we have discussed. Fine. Thank you very much for being with us for this 1 hour, and I hope the show was useful and we exchanged some good information. Thanks for attending this. Have a nice day ahead. I'll write back to you. Thank you.